If there is a technology that can unleash destructive power comparable to tactical nuclear weapons, without triggering the alarm of the international nuclear non-proliferation regime, will it become the ultimate answer to rewrite the rules of modern warfare and the energy landscape? In the spring of 2025, the silver fireballs rising from the Gobi Beach in northwest China gave a shocking revelation. When the world's attention is focused on artificial intelligence and quantum computation, Chinese scientists have found another way to connect military change and the energy revolution in such seemingly ordinary hydrogen storage materials. When the world's attention is focused on artificial intelligence and quantum computation, Chinese scientists took a different approach. In magnesium hydride, which seems to be an ordinary hydrogen storage material, to find the key to connect the military change and energy revolution. This seemingly accidental breakthrough is actually the inevitable result of more than 10 years of China's deep cultivation in the field of materials science. From the labs of new energy vehicles to the weapons targets of plateau testing grounds, from the engineering drawings of power grid storage stations to the negotiation table of the United Nations Conference on Disarmament, this technology is reshaping the logic of the real world at an astonishing speed. The breakthrough began with a breakthrough in the hydrogen energy bottleneck. A team of researchers discovered that magnesium hydride particles modified with nanoscale surfaces can release stored hydrogen at a rate of 1/1,000,000th of a second under the action of a specific catalyst, and its instantaneous hydrogen release rate is 100,000 times higher than that of traditional materials. This innovation was originally used to solve the problem of fuel cell range, but in the weapons test site to show the amazing potential, when 1 kilogram of modified magnesium hydride is detonated by conventional explosives, the release of chemical energy is equivalent to 3.2 kilograms of TNT. The more critical is that its high temperature of 2000 degrees Celsius can continue to bake the target for up to 2 seconds. This slow cooker energy release on the destruction of modern precision weapons, far more efficient than instantaneous explosions. In a sea area of the Yellow Sea in the live fire test, loaded with magnesium hydride combatant anti-ship missile, successfully melted through the simulated aircraft carrier deck of 12 layers of special steel composite structure, high-temperature jets and even erosion of the electronic equipment hidden behind the 3 bunkers. Amazingly, the magnesium oxide powder left over from the explosion drifted down in the test sea, tested by the Ministry of Ecology and Environment. Its pH value and the natural composition of seawater is fully compatible, without the expected chemical weapons pollution controversy. Military experts are keenly aware of the strategic value of this technology. Compared to tactical nuclear weapons, which require a complex nuclear security system, magnesium hydride devices do not need to violate the Treaty on the Non-Proliferation of Nuclear Weapons, NPT, but can also carry out quasi-nuclear strikes on strategic targets such as aircraft carrier battle groups and underground command posts. 2026 Taiwan Strait Crisis Simulation shows that 300 magnesium hydride missiles, deployed off the coast of Fujian Province, can cover 70% of the military installations in the Penghu Islands by thermal radiation, while the political cost is only the cost of using conventional ballistic missiles. More subtly, the weapon's non-nuclear attributes make it perfect for staying outside the limits of the INF Treaty. When the US protested against China's deployment of related equipment in the South China Sea Islands, Chinese diplomats simply tapped their tablets to submit an analysis of magnesium hydroxide's chemical composition to the United Nations, and all accusations were lost. All the accusations lose their focus. The international strategic landscape rippled. The Pentagon urgently launched a high-temperature protection program, investing $4.2 billion to retrofit the hulls of aircraft carriers with silicon carbide ceramic armor, a material originally used for the space shuttle's heat-insulating tiles, which has caused the cost of building the Ford-class carriers to soar to a staggering $18 billion. Japan's defense ministry secretly modified its Type 07 self-propelled artillery in an attempt to extend the range of magnesium hydride munitions to North Korea's Sinpo submarine base, only to have the fuel compartment overheat and explode during a test fire, exposing the haste and risk of grafting the technology. Russia, on the other hand, secretly tested a similar weapon system in the permafrost zone of Siberia, and the residual heat it released accidentally melted the ice in a 5-kilometer radius, exposing the remains of ancient mammoths in the news, which instead became a black humor for the international media to flirt with. Even more far-reaching are the geopolitical changes in energy. In Shanxi Yulin Hydrogen Industrial Park, Heavy trucks equipped with magnesium hydride storage tanks are coming off the production line at a rate of 300 per day, and the range of these mobile hydrogen storage stations has exceeded 1,500 kilometers, which makes it no longer necessary to refill hydrogen halfway through the trunk. Logistics from Kashgar, Xinjiang to Lianyungang, Jiangsu Province. The 2 GWh energy storage system constructed by State Grid in Tauratan, Qinghai, has a construction cost that is 40% lower than that of lithium batteries, and it can operate stably in the winter of Mauve at -40 degrees Celsius. The most unexpected is the Tibetan Plateau herdsmen. They use refrigerator-sized hydrogen storage device to replace the ancestral generations of cow dung fuel. The night tent LED lights in the light, and the Milky Way in the sky formed across time and space echoes. This deep synergy between civil and military development model, making China in the breakthrough technology transformation of the Valley of Death, when the unique advantage, the military to provide extreme environmental test data, civilian market to feed the scale of production, academic institutions are constantly optimizing the performance of the material, the formation of closed innovation ecosystem. When the International Energy Agency calculations show that magnesium hydride technology can reduce the cost of green hydrogen to $1.8 kg, the global energy market ushered in an earthquake. Saudi Aramco's stock price plummeted 5% in a single day. Russia's Lukoil urgently called off its Arctic Circle LNG project, and U.S. shale oil giants began collectively lobbying Congress to list magnesium hydride as a strategically competitive material. China's control of 72% of the world's magnesite resources, but also to make this change is full of geopolitical tension. The Tsadam Basin in Qinghai, the purification plant roaring day and night, 99.9999% of high-purity magnesium, along the new Silk Road train to the Yangtze River Delta high-end manufacturing base. While the European Union had to reopen the Norwegian magnesium mines that have been closed for 30 years, but found that the impurity content exceeded the standard, resulting in hydrogen storage efficiency plummeted by 40%. This strategic layout of resources and technology is quietly loosening the petrodollar system that has lasted for half a century. Technological breakthroughs are often accompanied by ethical controversies. The debate in the Conference on Disarmament in Geneva lasted 3 weeks, and representatives of various countries fought over whether magnesium hydride weapons violated the Convention on Certain Conventional Weapons. The British arms control experts cited Protocol III of the Convention, emphasizing that the use of weapons with combustion as the sole mechanism of killing should be restricted. The Chinese delegation played a video of the test on the spot, pointing out that after the explosion did not result in the sustained flames of a traditional incendiary weapon, but rather in an instantaneous release of chemical energy. Environmental organization, Green Future, protesters broke into the venue, holding up signs. Magnesium oxide dust harms the ecosystem, but was quickly quelled by scientists with data. The concentration of magnesium oxide in the atmosphere needs to reach 200 mg/m to affect plant photosynthesis, and test data show that the peak concentration of the explosion site is only 0.3 mg/m. Most ironically, when NASA announced that it would be using magnesium hydride fuel cells in the Artemis program, all the skepticism was turned into a fervent pursuit of technological dividends. After all, the performance advantage of continuous power supply for 14 days on the dark side of the moon was enough to silence any moral controversy for a while, just as the early days of nuclear energy development in the last century have been revisited. Looking back at the silver flame on the Gobi Beach, it is neither as frightening as the mushroom cloud of a nuclear explosion, nor as idealistic as the slogan of new energy. This paradoxical unity precisely reflects the complexity of the real world, when technological breakthroughs blur the boundaries between military and civilian use, and when the energy revolution and strategic deterrence coexist. What mankind is witnessing may not be the triumph of a single technology, but the modern interpretation of an ancient civilization's turning war into peace.